Okay, in our previous video, we worked through a couple of examples related to implicit differentiation. And let's go ahead and look at the practice of implicit differentiation where we do not have the work already done for us. So here we have a problem and we want to determine the value at the point 2,4. So in other words, the slope at the point 2,4. So I'm going to differentiate here, differentiate both sides, the derivative with respect to x, and I'm going to do it with respect to both sides. So derivative of x is 1 plus 2. Then I have the product rule, x times the derivative of y plus y times the derivative of x minus the derivative of y squared times y prime. That's the implicit differentiation. And then that's going to be equal to 0. Now, at this point, I could go ahead and substitute in my values if I wanted to, because I want to find out dy dx at the point when x is 2 and y is 4. So that means that I have 1 plus 2 times, all right? Well, my value for x is 2, so then I have 2, all right, times y prime plus the y value is 4, so then I have 4 times 1. And then I have minus 2, right? And the value of y was 4, and then times y prime. And ultimately, I'm trying to find the value of y prime, so I'm trying to solve for y prime. So if I make these manipulations, do a little bit of work, I've got 1 plus 4y prime plus 8 minus 8y prime is equal to 0. All right, continuing with the work, that would have 9 minus 4y prime is equal to 0. So therefore 9 is equal to 4y prime. And that would mean that y prime is going to be 9/4. So I have the value of y prime. And if I wanted to determine an equation for the tangent line, I would be able to do so. Okay. Next example, right, just says, right, what is dy dx when x is equal to 2? So I'm going to need to find the derivative, but I also need to figure out the y value when x is 2. So if x equals 2, I'm going to have 4 plus 2y being equal to 10, right? Which means that y must be equal to 3 because 4 plus 6 is 10, so y is 3. Now differentiating 2x plus, then my product rule, x times the derivative of y plus y times the derivative of x, and the derivative of x is 1, so times 1, and then the derivative of 10, that's 0. So I know x is 2, y is 3, so 2 times 2 plus x is 2, y prime plus y is 3 times 1 equals 0. So 4 plus 2y prime is equal to, not equal to 3. 4 plus 2y prime plus 3 is equal to 0. All right, if I continue with my work, that means that 7 plus 2y prime is equal to 0. So that means that 2y prime is equal to negative 7, and y prime, which is just another way of writing dy dx, right, that's going to be negative 7. Okay, negative 7 halves, excuse me, right, need to divide by 2. Okay. Now, another way of writing this notation is to say dy dx being evaluated at the point where x is 2, y is 3, and that value is negative 7 halves. Okay. Let's look at another example here. All right, what is the slope of the line tangent to the curve at the point? Okay, so we got this piece, we're given our point. So let's go ahead and find our derivative. All right, we need to find the derivative, 3y squared, that's going to be 6y y prime minus 4x being equal to 0 minus 2 times product rule. So x times the derivative of y plus y times the derivative of x. And we're doing this with respect to x. That's why the derivative of x is 1. And I need to find the slope of the line tangent. So really this is saying we need dy dx at that point 3, 2. So that's going to be 6 times 2 times y prime, because the y value is 2, minus 4 times 3 is equal to 0, minus 2 times, right, x is 3, so that's going to be 3y prime plus y is 2, so then plus 2. Right, so 12y prime minus 12 is going to be equal to negative 6y prime minus 4. If I move my items around, forgot the y prime here. Let's add 6y prime to both sides and add 12 to both sides. All right, so I can do this like you might have done in elementary school or middle school, say plus 6y prime, right, plus 6y prime, plus 12. Make sure we balance our equations. And that'll give me then 18y prime is going to be equal to 8. So then y prime is going to be 8 over 18. And once again, if this is a free response question, simplifying is not necessary. But if your professor wants you to simplify, be sure that you do. And if this is a multiple choice question, then you'll likely see the simplified answer of 4/9. Okay. And one more example for this video. We have if x squared y minus 3x equals y cubed minus 3, then what is dy dx at the point negative 1, 2? Okay, so go through. We have a product rule here. X squared times the derivative of y plus y times the derivative of x squared minus the derivative of 3x equals the derivative of y cubed, 3y squared, times the derivative of y, and then the derivative of a constant is 0. Okay, some people like to solve for y prime before substituting, so we can do that here. So we would say that we have x squared y prime minus 3y squared y prime is equal to 3 minus 2xy. So y prime times x squared minus 3y squared is equal to 3 minus 2xy. Continuing with my work, that means that y prime, which is dy dx, is given by 3 minus 2xy all over x squared minus 3y squared. Now, dy dx evaluated at the point x is negative 1, y is 2, is therefore going to be 3 minus 2 times negative 1 times 2, the x value and the y value, all over negative 1 squared minus 3 times the y value squared. And if you need to simplify, you can, but for our purposes, we want to make sure you can get to this step of the implicit differentiation correctly. Okay? We'll have a few more examples in our next video. Thank you for your time.